Question 1. What is the foundational neural network architecture for most modern large language models, LLMs, like Claude AI? Option A. Recurrent neural networks, RNNs. Option B. Convolutional neural networks, CNNs. Option C. Transformer architecture. Option D. Support vector machines, SVMs. The correct answer is Transformer architecture. Here's the explanation. The overview and key features/components sections both explicitly state that LLMs are typically based on the transformer architecture, and that the transformer architecture is the foundational neural network architecture for most modern LLMs. Question 2. Which of the following best describes the pre-training phase of an LLM's development? Option A. Fine-tuning the model on a small, curated dataset to align with human preferences. Option B. Unsupervised learning on a massive, diverse dataset to acquire general language understanding and generation capabilities. Option C. Optimizing the model's parameters for a specific, narrow task like sentiment analysis. Option D. Manually programming specific rules for language grammar and syntax. The correct answer is unsupervised learning on a massive, diverse dataset to acquire general language understanding and generation capabilities. Here's the explanation. The key features/components section on pre-training and fine-tuning/alignment explains. Pre-training involves unsupervised learning on massive datasets to acquire general language understanding and generation capabilities. Question 3. What are emergent abilities in the context of large language models? Option A. Capabilities that are explicitly programmed into the model by developers. Option B. Features that are primarily used for tokenizing input text. Option C. Capabilities that appear in LLMs only once they reach a certain scale, such as in-context learning or complex reasoning. Option D. The ability of an LLM to automatically reduce its parameter count during inference. The correct answer is capabilities that appear in LLMs only once they reach a certain scale, such as in-context learning or complex reasoning. Here's the explanation. The key features components section defines emergent abilities as capabilities that appear in LLMs only once they reach a certain scale, number of parameters, and training data. These abilities are not explicitly programmed but emerge from the vastness of their training, such as in-context learning, complex reasoning, or instruction following. Question 4. What is the primary innovation introduced by the transformer architecture that allowed it to overcome limitations of previous models like RNNs and LSTMs? Option A. The use of recurrent connections to process tokens sequentially. Option B. The implementation of convolutional layers for local feature extraction. Option C. The self-attention mechanism, enabling parallel processing and capturing long-range dependencies. Option D. A significant increase in the number of hidden layers without residual connections. The correct answer is, quote, the self-attention mechanism, enabling parallel processing and capturing long-range dependencies. Here's the explanation. The overview section states the transformer revolutionized how models process sequential data by entirely eschewing recurrent RNNs, LSTMs, and convolutional layers in favor of a mechanism called attention. This allowed transformers to overcome the limitations of previous architectures, particularly in processing long-range dependencies and enabling parallel computation. Question 5. Why is positional encoding a crucial component in the transformer architecture? Option A. It compresses the input embeddings to reduce computational cost. Option B. It adds information about the absolute or relative position of each token, as self-attention does not inherently understand word order. Option C. It replaces the need for multi-head attention by directly encoding semantic relationships. Option D. It normalizes the inputs across features, preventing vanishing gradients. The correct answer is, it adds information about the absolute or relative position of each token, as self-attention does not inherently understand word order. Here's the explanation. The Key Features/Components section explains. Since the transformer processes sequences in parallel without inherent sequential order, positional encoding adds information about the absolute or relative position of each token in the sequence. Question 6. For generative models like Claude AI, which are typically decoder-only transformers, what is the significance of masked multi-head self-attention in the decoder stack? Option A. It allows the model to process the entire output sequence bidirectionally during training. Option B. It prevents a token from attending to subsequent tokens in the output sequence during training, ensuring causal language modeling. Option C. It exclusively focuses on the encoder's output, ignoring previously generated decoder tokens. Option D. It reduces the number of parameters needed for the attention mechanism. The correct answer is, it prevents a token from attending to subsequent tokens in the output sequence during training, ensuring causal language modeling. Here's the explanation. The How It Works section on the decoder stack states, masked multi-head self-attention. Similar to the encoder's self-attention, but with a crucial difference. It's masked. This masking prevents a token from attending to subsequent tokens in the output sequence during training, ensuring that the prediction for a given token depends only on previously generated tokens. Causal language modeling. Question 7. What is the primary operational impact of a high token count in both input prompts and generated responses when interacting with Claude AI? Option A. It significantly increases the accuracy of Claude's responses regardless of the prompt quality. Option B. It directly impacts API costs and can increase processing latency. Option C. It allows Claude to access and process an unlimited amount of external knowledge. Option D. It reduces the need for prompt engineering by providing more context automatically. The correct answer is, it directly impacts API costs and can increase processing latency. Here's the explanation. Tokens are the fundamental units for billing and processing in LLMs. Higher token counts for both input and output mean higher API costs and generally longer times for Claude to process the request and generate a response, thus increasing latency. Question 8. An agent is designed to maintain a long-running, multi-turn conversation with a user about cloud architecture. What is the main challenge presented by Claude's context window in this scenario, and how is it typically addressed? Option A. The context window is too small to hold any meaningful conversation. It's addressed by sending only single-turn prompts. Option B. The context window has a fixed maximum size, limiting the total tokens, input plus output, which is addressed by strategies like summarization of past turns or intelligent retrieval. Option C. The context window is dynamic and expands infinitely, leading to exponentially increasing costs. It's addressed by setting a strict max tokens to sample. Option D. The context window causes Claude to forget information too quickly. It's addressed by increasing the model's temperature. The correct answer is, the context window has a fixed maximum size, limiting the total tokens, input plus output, which is addressed by strategies like summarization of past turns or intelligent retrieval. Here's the explanation. Claude's context window has a fixed maximum size, meaning that for long conversations, older parts of the dialogue must be pruned or summarized to keep the active context within limits. This prevents errors or truncations and ensures coherence without exceeding token limits. Question 9. What is the key advantage of using embeddings for tasks like semantic search, in an enterprise knowledge base compared to traditional keyword matching. Option A. Embeddings guarantee 100% exact matches for all search queries. Option B. Embeddings reduce the computational resources required for search queries to almost zero. Option C. Embeddings capture the semantic meaning and context of text, allowing for the retrieval of conceptually similar information even without exact keyword matches. Option D. Embeddings provide a human-readable summary of the search results directly. The correct answer is, embeddings capture the semantic meaning and context of text, allowing for the retrieval of conceptually similar information even without exact keyword matches. Here's the explanation. Embeddings represent text in a high-dimensional space where semantic similarity translates to vector proximity. This means they can find relevant documents even if the exact keywords are not present. Unlike traditional keyword matching, which relies on lexical overlap, they capture the to-the meaning of the text. Thanks for watching. Please subscribe to my channel.